Welcome back. Glad to have you. We're going to do 11.3 today. And 11.3, I say this not to scare you, but more just to prepare you. 11.3 might be a little bit tricky. And one of the examples that we do might be one of the harder ones we do in this entire class. But I believe in your abilities. Okay? We're actually talking about area of all different types of polygons, and there's a formula that will be able to guide us there. We'll look at that in just a second. But to make something that's, or as you work with area of polygons, you should be hoping that the question is a rhombus or a kite, because the formula is a lot simpler with a rhombus and a kite. You take the diagonals, multiply them together, cut it in half, and you got your area. And that's for a rhombus and a kite. So when we look at this example right here, the area is half of the diagonals multiplied together. The diagonal is 8. The other diagonal is 6. Half of 8 times 6 is 24. So 24 square meters is the area of that rhombus. The area of the kite would be the same thing. 1/2 7 times 10. Half of 7 times 10 is 35. So the area here would be 35 square centimeters. And if that's all we were doing, this would be a really easy lesson, but you know better. Math can't be quite that straightforward. We need to make it a little bit more complicated. So we need a formula for the area of a regular. Remember, regular means all the sides are the same length, and the angles then are also the same measures. And the formula for that is this. You take the area, or to find the area, it's 1/2 the apothem, which I'll talk about in just a second, times the perimeter. Perimeter, remember, is just all the sides added together. Cut that in half, and then multiply by the apothem. And now what the apothem is, I'll put a note up here, is the distance from the center to any side. And I'll draw it so that you can get a visual representation of that. But what the apothem is just the distance from the center of the shape to any side. Oh, that's bad. Okay, so we're going to pretend that this is a good drawing. Now, here's a hexagon. Here's the center of the hexagon. The apothem would be this distance right here. It comes straight down, and it's always going to meet at 90 degrees because this is going to be a horizontal meeting a vertical. So that will always form a 90-degree angle, which will be very important for us. So that distance right here, this distance is the apothem. So you take this distance times the perimeter, cut it in half, and that would be how you find the area of any regular polygon. So regular hexagon, regular octagon, regular dodecagon. This formula would hold true. Okay. So just some terminology here, and then we'll jump into a couple maybe a little bit more challenging examples. Okay. In this diagram, A, B, C, D, E is a regular pentagon inscribed in a circle. Okay, so that's just fancy for if it's inscribed, what that means is that each of the points touches the circle exactly once. So the circle goes around it, and it hits at all of these vertices. So identify the center and all of this up. So the center of everything, the center is F. Right, that's smack dab in the center of both the circle and the pentagon because it's inscribed in the circle. They share a center. The radius is from the center of the circle to the edge. So there's actually two different answers that you could put here, either FB or FA. That's the radius. That's the radius. The apothem, that's the new one that we learned. The apothem is the distance from the center to any side. Okay, so your apothem is going to be here, FG, hits at 90, and it hits at the side AB. So the apothem is FG. Central angle, that is just the angle in the center. So the central angle is angle BFA. This entire angle right here, that's my central angle, BFA. Find each measure. So to find the central angle, BFA, or as it's written down here, AFB, to find the measure of the central angle, basically what you're thinking about here is because it's inscribed in a circle, you can think of it as part of a circle. So how many of these angles could I draw in the circle? There's 1, there's 2, 3, 4, and 5, right? 1, 2, 3, 4, 5 of these. I could draw 5 of those angles, and I would fill the circle. And since there's 360 degrees in a circle, this number would just be 360 divided by 5. Because 360 is in the whole thing. I can make 5 of them, so 360 divided by 5 is 72 degrees. So this entire angle right here, this central angle is 72 degrees. Okay. Angle AFG, that's not the whole thing, it's actually just going to be half of that central angle. So you're going to take this central angle, cut it in half, and get 36 degrees. So this is 90. This piece right here is 36. To find the measure of GAF, what we'll do is, since we know there's 180 degrees in a triangle, we'll subtract off the angles that we know, and 180 minus 90 minus 36 is 54 degrees. Okay, so since there's 180 degrees in this triangle right here, we know that this one's 90, this small piece right here is 36. 180 minus 90 minus 36 gives us this GAF angle, which is 54 degrees. And we're going to use that fact here in a little bit. As we do this example, the next two examples, they are very challenging. So try to pick up as much as you can from this, and then you'll be able to work on it in class, and hopefully it'll stick in a little bit more. Okay, so we have a 9-sided figure, and we're trying to find the area of the 9-sided figure. Remember now, the area is 1/2 apothem times the perimeter. So what I need to do is I need to find the length of the apothem, I need to find the perimeter, and then as soon as I have those things, I will be able to solve for the area. Okay. Well, in looking at this right now, I don't know this length. This right here would be the apothem, LM. I don't know that length yet. And then I also don't know this side length over here, because if I knew this side length, I could multiply that by 9 to get my perimeter, right? Because I have 9 of those. So I actually don't have either one of these pieces of information readily available. So I need to kind of work backwards. And we're going to have to use the stuff from the previous unit to get us there. So first take a look. Notice what is the measure of that central angle? Well, the measure of that central angle right here is going to be whatever 360 divided by 9 is. Since I have 9 sides, I'd be able to fit 9 of these wedges in here. And if the whole thing is 360, I'll divide that by 9 and get 40. So the central angle is 40. And if the central angle is 40, then each of these smaller pieces would have to be 20. So angle, let's just say angle KLM. It has to be 20 because it's exactly half. So if I actually just take this triangle and just draw it down here, K, J, L, what do I know? I know that this is 90, and I figured out that this is 20 degrees right there. This length right here, L, oh, excuse me, this is an M, sorry. That's M right there. I'm copying just this smaller triangle. This length right here, this is my apothem. So it'd be really nice to know this, how long this is, because then I could use it in my equation. So I'll solve for the apothem. How will I do that? Well, what I have is I have a right triangle where I'm trying to solve for this side. Can we do that? And yes, we can. Because we know that this distance over here is 4. It gives us that up here. This is a 4. So my hypotenuse is 4. And I'm solving for this side right here, A, my apothem. It's also A because it happens to be my adjacent side. From the 20, here's opposite, here's adjacent, here's hypotenuse. So if I'm solving for adjacent, and I'm going to use the hypotenuse to help me, A and H, I'm going to use cosine. So the cosine of my angle, cosine of 20, is the apothem over the hypotenuse, A over H, apothem over 4. And now remember, when we solve this, you do the cosine of 20 on your calculator. To get rid of a divide by 4, you'll multiply each side by 4, and you find out that the apothem is equal to 3.76. 3.76 is that side length. So that's good. I got this distance, but actually I'm not quite done because I still need to find the perimeter of this thing. And so to find the perimeter of this, I need to know how long are each of the sides in the nonagon. Okay, so now I'm going to come back to this triangle, and now I'm not going to solve for the apothem. I'm actually going to solve for O. My opposite side is this piece right here, this smaller piece. So I'm going to solve for my opposite side now. So if I'm solving for opposite using the hypotenuse, now I'm going to use sine. So the sine of 20 is equal to, I'll just label this with an x, x over 4. Once again, sine 20 on your calculator, multiply each side by 4, and you find out that the side length is 1.37. Okay, and that's just the trig from the last time. Now, there's two different ways that you can think about this. One, this is just half of, this km is half of a side length. So you could double this. If you doubled it, you would get 2.74, which means all of these are 2.74. And then you multiply that by 9, because it would be 2.74 plus 2.74 plus 2.74, and so forth. Okay. Another way that you could think about it is if you have 9 sides, you have 18 half sides. So then you can multiply this by 18. I'm just going to think about it more traditionally. And so what I'm going to do then is I'm going to take this and multiply by, that was an x, multiply it by 2, which gets me 2.74. So now I know that each of these lengths are 2.74. And then now to find the perimeter is all those 2.74s added together. Or you can just, I got 9 of them, so you can do 9 times 2.74, and you get 24.66. So that was a lot of work, and we're actually not done. Some of the work was to find the apothem. Some of the work was to find the side length. And then you use that side length to find the perimeter. Now lastly, we can actually solve it because we have the information that we need. We're looking for 1/2 apothem times perimeter. 1/2 apothem times perimeter. 1/2. Solve for the apothem, we solve for the perimeter. You throw that into your calculator and you get 46.36, and that is in square units. Units, that's just a U squared, it just stands for units squared. Since I didn't put like meters or inches or anything, I'm just using units. So a lot of work there, piggybacking off what we did in the previous unit with trig. We needed the trig to find these side lengths. Okay. Once we had the side lengths, we could solve what we're looking for. So a lot of stuff there, 5 steps as you can see, but hopefully you're able to stay with me through all of them. Okay, do this last example, then we will be done. We have an octagon, and we're trying to find the perimeter of this regular octagon. Or sorry, trying to find the area of this octagon. Once again, I'm going to use this formula, apothem times perimeter. So we need to know perimeter and we need to know apothem. The nice part about this one actually is that we have a side length. One of the side lengths is 15. So you can do 15 plus 15 plus 15 plus 15, yada, 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 yada. Okay, or you can just do 15 times 8, and that's equal to 120. So we have found our perimeter, it's 120. Now we just need to go find our apothem. When we get our apothem, we'll be done. So I'll come into this here. What I'm going to do is on here, I'm going to actually draw a triangle. I know that the radius is 19.6. Drawing my apothem is this height right there. That's my apothem. So if I can figure out that height, then it would be wonderful. Okay. The apothem is going to come in, and since it's this, since it's a regular polygon, it's actually going to come in and cut this in half. So then, if the whole thing is if the whole side is 15. This is 15. Cut 15 in half, and then this distance right there would have to be half of 15, which is 7.5. And I know that this hypotenuse over here is 19.6. So I know this is 7.5. I know this is 19.6. To solve for the apothem, that's the third side in a right triangle. To solve for a third side in a right triangle, you can always use the Pythagorean theorem. A squared plus b squared equals c squared. 7.5 squared plus the apothem squared is equal to 19.6 squared. So you do 7.5 squared and you get 56.25. 19.6 squared in my head is 384.16. I'm a mathematical genius. Subtract 56.25 from each side. And when you do that subtraction, 384.16 minus 56.25, once again in my head, is 327.91. Take the square root of each side, and my mathematical genius tells me that the square root of 327.91 is roughly 18.108. So I've solved for my apothem. I already knew my perimeter. So now I can use the formula. The formula, once again, 1/2 apothem times perimeter. So I do 1/2 times my apothem, which is 18.108, times my perimeter, which is 120. Throw that into your calculator, or if you're a mathematical genius like me, you can do it in your head, and you get 1,086.5, and that is square inches. So you're decorating this with ceramic tile. That's how much you are going to use, 1,086.5 square inches. Right. Tricky, I know, but basically find your perimeter somehow, find your apothem somehow. You're likely going to either use Pythagorean theorem like we did here, or trig like we did here to help you along the way. Good job.